look at the vector that's produced when I write 8 colon 7 colon 100. So it goes 8, 15, 22, etc. Starts at 8, goes up by 7, never goes past 100. And what I want to ask is, what's the first prime inside of this vector? So in this case, the first prime, first number whose only positive divisors are 1 in itself, is 29. So I want to write a function that finds this sort of first prime. And I'm going to make a new function here, and the name I'm going to give to it is Dirichlet. And the reason for that is because there's a mathematician named Dirichlet, and he has a theorem in number theory which says that under certain conditions, there's always not just one prime in this kind of sequence of numbers, which is called an arithmetic progression, but there are actually infinitely many primes in these sorts of arithmetic progressions. So let's go ahead and do that. I'm going to call A for my starting number. So A would be the 8 in this case. I'm going to call M for the step size. So in this case, M is 7. Go up by 7. And then my output, I'm going to call it P. Think of that as being a prime. And how do I want to do this? Well, there are some different ways. Let me show you one way. And the key thing that I want you to think, and the thing that's related to the recent videos, is why are we going to use a while loop instead of a for loop? The reason we use a while loop in this case is because I don't know how many times I have to add m until I find a prime number. Maybe a is already prime, then I don't have to add m at all. Maybe I have to go 50 steps before I find a prime number. So that's the reason why it makes sense to use a while loop instead of a for loop. You use a while loop when you want to go on indefinitely. You use a for loop when there's some definite spot that you want to stop. So I want to think of x as how many times I've added m. So I'm going to start with x equals 0. So for example, a plus m times 0 is just a. That's where I start with. And then I want to know, is a plus m times x prime? So if I just write this, I'm going to get an error because there is no mx. I have to put a multiplication sign between the m and the x. And what do I want? Well, let's test this out here. It's not going to work. Right now it says while is prime a plus m times x. And then what am I doing? What's my loop supposed to do? It's supposed to be increasing x by 1 each time. So first I add 7, then I add 2 times 7, then I add 3 times 7. For example, 8 plus 3 times 7, 8 plus 21 is 29. So here inside the loop, I say x equals x plus 1. And then once I've found a prime, then I do p equals a plus m times x. Okay, the prime that I found. So I'm going to name this Dirichlet. And let's just go test it out. So let's test it with these exact inputs. So I don't need the 100. That's the whole point of using a while loop. In theory, it could just go on forever. So I'm going to try Dirichlet 8, 7 and see what happens. So it definitely didn't work. It was supposed to output the first prime that's of the form 8 plus 7 times x, but 8 is not prime, so something went wrong. Okay, and the problem is when I got to the very first one, which was 8, it said while is prime 8. So while false, that's how you should think of this. And then it just jumped down here, set p equals 8, and then it finished. So this is actually the exact opposite of what we want. What we want can be gotten by putting a tilde in front of it. So this negates it. So now instead of asking, is it prime, true, false, now I'm asking, is it not prime, true, false? Okay, and now it's going to work. So I saved it. Now let's check. Yep, that worked. Dirichlet 8, 7 gives me 29. In the language of Math 13 or Math 120, 29 is the first number bigger than 8, or bigger than or equal to 8, which is congruent to 7 mod 8, which is prime. So you can use this to find lots of interesting examples. If I do Dirichlet, how about, well, I guess 3 is a bad number to start with because 3 is prime. So if I do this, I'm just going to get 3. But let's try Dirichlet 9, and how about 2? Then I get 11. How about 9 and 4? Then I get 13. How about 9 and 5? Then I get 19. How about 9 and 13? Okay, there's an interesting one. I get 61. So what are the numbers that show up? We can look at them. Start by 9, go up by multiples of 13. And let's stop at 100, say. So then I get 9, that's not prime. 22, that's not prime. 35, that's not prime. 48, that's not prime. 61, that is prime. Okay, another one I could do would be Dirichlet 911. That works. What about Dirichlet 912? Okay, now it seems to be stuck. And what happened? Well, this is actually the reason why I named this video Programming Pitfall. Something that you'll find happens a lot when you're working with while loops at the beginning is you might accidentally create an infinite while loop. So I'm going to cancel this, and what I want you to know is that you cancel some sort of stuck MATLAB operation by holding down Control and hitting C. Okay, so I did that. I get this operation terminated warning. And so let me try to explain why I got into an infinite while loop. Remember, it's looking for a prime number. So let's look at 9, 12, 100. So 9, is that prime? Nope. 21, is that prime? Nope. 33, is that prime? Nope. And so not only are none of these prime, but actually they're all multiples of 3. And so Dirichley's theorem, it doesn't say that you always get infinitely many primes. It says that if your two numbers, in my case the 9 and the 12, don't have any common divisor, then you get infinitely many primes. But in this case, when I do 9 plus 12 times x, that's always going to be divisible by 3.